Welcome to Honors Geometry, Lesson 12.1, Introduction to Solids. And we're going to talk about solids as being closed figures. Think about a polygon as a closed figure in a plane. Solids are closed figures in space. And like polygons, they have some certain rules that have to apply to them. Now, some of the solids in this picture are polyhedra. That's the plural of polyhedron. Okay? I'll show you the ones that are polyhedra. Check, check, check. In fact, all the checks I'm making right now, the special form of polyhedron that these are prisms. There. All of those are polyhedra. The next set are also polyhedra. The special name for those polyhedra are pyramids. And then the rest of them that I haven't marked at all, those solids are not polyhedra. So can you guess what differentiates all of these from the solids that I did not check? Well, here it comes. Polyhedra. A polyhedron is a solid whose faces are all polygons. Let's look at this prism right here. You're going to name that prism by its two faces that are congruent to each other. Those two congruent faces that are congruent to each other are triangles. So this is a triangular prism, named for its two faces that are congruent to each other. Those congruent faces, we are now going to call them bases. Alright? Those are the bases, the congruent faces. So the base of the prism is how you name it. And then it will have lateral faces. The lateral faces of all polyhedra that we're going to look at, sorry, that's not correct. The lateral faces for all prisms that we're going to look at are rectangles. So every face on this triangular prism, every lateral face is a rectangle. So you got two triangle faces called bases, and then three lateral faces, and they're all rectangles. So the faces are the flat surfaces. Where two flat surfaces meet, that's an edge. Where the two faces meet. And then of course each place where edges meet are called a vertex, and of course the plural for vertex is vertices. So looking at that triangular prism, how many faces does it have? It has two triangles and three lateral rectangles. That would be 5 faces. How many vertices does it have? Let's see here. 1, 2, 3, 4, 5, 6. It has 6 vertices. And how many edges does it have? Okay, we'll do those in green. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. It's got 9 edges. Let's go ahead and look at our next prism. This, because it has a rectangle on the bottom, It's called a rectangular prism. And I can't really tell right now if it's a square prism, and if it was a square prism, or if all the faces were the same size, of course, this rectangular prism would become a cube. A cube is kind of like what a square is to a rectangle. Okay, so that's what a cube is in relationship to a rectangular prism. Okay, how many faces? Well, obviously 6 if it's a cube. And how many vertices? 1, 2, 3, 4 on the top, 4 on the bottom, 8. And how many edges? 4 on the top, 4 along the lateral faces, and then 4 along the bottom, 12. And now we will look at the next prism. This prism, don't let it mess with your eyes too much. This is kind of looks like a Monopoly hotel, and you're looking at the roof of it, and you're looking at this bottom part. You can't see the top. So this has, okay, the 2 bases. What shape are those? Yes, they're pentagons. So this is a pentagonal prism? No. You have the emphasis on the wrong syllable. That is a pentagonal prism. Yeah, I know. Oh, you're such a stickler for details, Manning. I know. How many faces? Well, you got the 2 bases. That's 2, and then 5 lateral rectangular faces, total of 7 faces. Vertices. 5 on the top, 5 on the bottom, 10 vertices. And how many edges? 1, 2, 3, 4, 5. Wait a minute. 5 along top, 5 along the laterals, and 5 on the bottom. Total of 15. Alright, and then this German guy named Euler, he figured out something really cool. He said, you know what? If you look at the number of faces, vertices, and edges, there is a mathematical relationship. And what he found out is that the number of faces plus the number of vertices is always going to equal the number of edges plus 2. How he ever noticed that, I don't have a clue, but I think it's pretty cool. Alright, let's move on and take a look at pyramids. Pyramids, again, are going to be named by the base. In this case, the base is a triangle. So this is a triangular pyramid. Whoops. Might help if I spelled correctly. Okay. How many faces? It's got 4. How many vertices does it have? It has 1, 2, 3, 4 vertices. So that means it should probably have 6 edges. 1, 2, 3, 4, 5, 6. It does. Sweet. And this pyramid is a rectangular pyramid, because it has a rectangle for a base, and that base is right along there. Okay, how many faces does it have? Well, it's got 1 base that's a rectangle, and then 4 lateral faces, which are all triangles, for a total of 5 faces. Vertices, it has 1, 2, 3, 4, 5 vertices. That means it probably has 8 edges. 1, 2, 3, 4, 5, 6, 7, 8, and it does. Okay, all the lateral faces on pyramids, they are going to be triangles. The lateral faces on prisms, rectangles. The lateral faces on pyramids, triangles. All right, let's look at the ones from the front page that I did not check off. this, this, and this. What do all those have in common? Well, they don't have all polygons as faces. And those, the three most common that are not polyhedrons or polyhedra, the cylinder, the bases are circles, and the lateral face is kind of like a big rectangle when you fold it out. Okay, the cone has one base that's a circle, and then the lateral surface area is, it's actually a sector. It's really crazy. And then a sphere, it's just round all over the place. Anyway, this is a great introduction to solids. This does conclude lesson 12.1, Introduction to Solids.